Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to start with AMBA AHB protocol. So first of all, what do you mean by AMBA AHB protocol? So basically AMBA AHB stands for Advanced High Performance Bus. So it is a part of AMBA Advanced Microcontrollers Bus architecture family, which is designed to support high performance, high bandwidth communication between different components in a system on chip. So basically this AHB provides a single clock edge operation, burst transfers, pipeline structures, and making it suitable for high speed designs. So what do you mean by single clock edge operation? What do you mean by burst transfers, and what do you mean by pipeline structures? Everything we are going to cover in this course. Okay. Now, before going to start this course, first of all, let us be clear in two type of protocols. Let us first differentiate the protocols into two categories. One is on-chip protocols and another is peripheral protocols. Now before going to start this discussion also, first of all, let us be clear, what do you mean by protocol? Yes, what do you mean by protocol? So why we are learning these protocols? Why we are learning these so many protocols? Why we are learning this? What is the use? So basically, why we are learning this protocol is nothing but it is a set of rule. Okay. So for establishing a communication between two devices or multiple devices, we need someone. They need to follow something, right? They need to follow some protocol so that the data will be communicated successfully, or the communication will be established without any disturbances. Okay. So that is the use of this learning of these protocols. That is why we are learning these protocols, so that we can establish a good connection between your multiple components or different components. Okay, so that is why we are learning these protocols. So basically we have on-chip protocols and peripheral protocols. On-chip protocols will basically communicate between the components on a chip like an SoC, and coming to peripheral protocols, where your component is going to communicate with your peripheral devices. So these are your peripheral protocols and on-chip protocols. So coming to on-chip protocols, first we are going to discuss about AMBA AHB protocol, and next we are going to discuss about AXI protocol. In our series only we are going to learn this APB protocol, and we are going to learn AHB protocol, and we are going to learn AXI protocol, and these three protocols we are going to learn in this course series. Okay. And coming to peripheral protocols, we are going to learn about UART. This is a very famous protocol, I2C, SPI. So these protocols we are going to learn. Okay. So on-chip protocols, AMBA, AHB, APB, AXI we are going to learn, and next peripheral protocols we are going to learn about UART, I2C, and SPI. Okay. So these are the protocols we are going to learn, and further after this we are going to learn Ethernet, DDR, everything we are going to see if time permits. Yes. So this is our agenda. So we are going to learn about on-chip protocols and peripheral protocols. Coming to on-chip protocols, we are going to learn about AHB protocol, APB protocol, and AXI protocol. And coming to peripheral protocols, we are going to learn about UART, I2C, and SPI. Okay. Yes. So coming back to AHB protocol, we are going to learn about what do you mean by AHB protocol. And first of all, let us try to understand what is AMBA. So basically, AMBA stands for Advanced Microcontroller Bus Architecture. This is a full form of AMBA. Now, it is a set of specifications. As I have said you, a protocol is nothing but a set of rules that if we follow, then there will be a good communication established between the components. Or if you are not following that particular set of protocols, you are not going to establish a communication, and you will not able to transfer any data. Okay. So basically this AMBA, it's a set of specifications developed by ARM for standardizing the communication between different functional blocks of an SoC. It is an on-chip protocol, and on an SoC we are going to use this protocol. Okay. So basically AMBA consists of multiple protocols including your AHB, APB, and AXI. Okay. So that's what we have seen on-chip protocols. So basically AHB, nothing but it stands for Advanced High Performance Bus. This AHB protocol is specifically for high speed, high bandwidth communication. Okay. So this AHB protocol is used for devices which are having high speed, high processing speed, and high rating, and those who are those components which is having high bandwidth communication. Coming to APB protocol, this protocol is specified only for low power, low bandwidth peripherals. This is mainly for low power and low bandwidth peripherals. Okay. And coming to AXA protocol, this is also for high performance and low latency and high bandwidth applications. So this is an advanced protocol compared to this AHB and APB. This AXA is little bit advanced. Okay. So this is what we are going to learn. Okay. Some common examples of AHB, like let's say suppose where we are going to use this AHB is, let's say this is an SoC, and let's say if we have a processor, and if our processor, let's say if it wants to communicate with some high performance device like DDR controller or some Ethernet controller. Okay, so in these cases we can use our AHB protocol for establishing this communication between your processor and your other component, which is a high speed device or high bandwidth device. Okay, so this is how we are going to choose our protocol. And if your processor wants to communicate with a peripheral device, right, so how it is going to communicate, it can use APB protocol for communicating with your peripherals. Okay, so we are going to use a bridge. There will be for conversion of your AHB signals to APB signals. Generally the processor will be using, so here the master or the processor will use this AHB signals, and if the signals wants to be converted into APB, then we need a bridge here. Okay, so using this bridge, AHB to APB bridge, we are going to communicate, the master or the processor is going to communicate with your APB slave. So these are the type of protocols, and why and which protocol is used for which one, and what are the type of protocols, and what is the full form of AMBA, and what is the on-chip protocols and peripheral protocols. That and all we have seen in this particular session. So in next video we are going to start about overview of AHB protocol. There we are going to learn what are the terminologies we are going to have, and what are the role of each and every component that we are going to learn in our next video. Yes. So that's all about this particular video. So if you like this video, please like, share and subscribe to my YouTube channel. And if you have any doubts or any queries, please feel to comment in the comment section. Now coming to overview of AHB protocol, so let us see. So basically this AHB protocol defines the interaction between three main components. So we have three main components. One is managers, or you can say them as masters, and another is subordinates, you can say them as slaves, and followed by interconnects. So basically this interconnect is used for handling the data routing and arbitration between the managers and subordinates. We are going to discuss about interconnects later. Now let us have our discussion on managers and subordinates. So let's say we have two components like this. Now which one is manager and which one is slave? So we cannot fix any component as a manager or a slave. So any component is not a manager permanently, or any component is not be said as a slave permanently. Okay, so when will be a component will be said to as a, now when will be a component will be said as a master, and when will be a component will be said as a slave. That is very important. So any component will not be permanently acting as a master, and any component will not be permanently acting as a slave. Okay, so here we need to understand the manager is a component which initiates the transactions by issuing write and read commands. So whichever the component initiates the transaction, so whichever the component is initiating the transaction, it may be a read transaction or it may be a write transaction. About the read and write transactions we are going to learn further in our sessions. Now for now we are just going to focus upon who is manager or master and who is slave or subordinate. Okay, so as I have said earlier also, no component is permanently a manager or a slave. Okay, no device is permanently a master or slave. So let's assume this as a manager. It is not a permanent manager, and let's assume this as a slave. Why I am saying this as a master? Because this component A is initiating the transaction, because this component is initiating the transaction, and this component B is responding to the transaction. This component B is responding to the transactions. So that's why I am labeling this component A as my master and the component B as my slave. So let's say after some time, if B starts let's say after some time, if the component B starts initiating the transactions and if the component A starts responding to the transactions, then obviously B will become master and component A will become slave. Okay, so the roles are interchangeable. You cannot permanently fix them. Okay, now, so that is our masters and slaves. So masters you can also call as managers. In the protocol specification, we have the terms like managers. So basically this managers initiate the transactions by issuing read and write commands, and whereas the subordinates or slaves, these respond to the manager's request and provide to store the data. Okay, and coming to interconnects, we will discuss in our later sessions about this interconnects in more detail. Now, what are the key features of AHB? So basically AHB protocol includes several essential features that optimize performance and efficiency in high speed designs. So what is the first feature we have? Well, that is single clock edge operation, and second one is burst transfers. This burst transfers it's a very important topic that we are going to discuss. And coming to single clock edge operation, the protocol operates synchronously on the rising edge of a clock, ensuring predictable timing. So it may be a read transfer, or it may be a write transfer, or it may be a burst transfer, or it may be any transfer. It may be any type of transfer. If master wants to send the data to the slave, or if the master wants to read the data from the slave, everything will be happening synchronous to the passage of clock. Okay, so that's why it is a synchronous protocol. And coming to burst transfers, we are going to learn it in more detail in our upcoming slides. What do you mean by burst transfers? What are the single type burst? What are the incremental burst? What are the wrapping burst? Everything we are going to learn. Okay. Now, let us try to understand AHB system components. So as we have already seen, AHB has a master that is also known as AHB manager. So the manager, why we are calling it as a manager or master? Because it is initiating the transactions on a bus. Okay. So basically here the let's say we have a master and we have a slave. So how these two are going to communicate with each other? So how the master and the slave are going to communicate with each other is via a bus. Via a bus. Now, what do you mean by bus now? So bus is nothing but it's a bundle of signals. Bus is nothing but a bundle of signals where using these signals, our master and slave are going to communicate with each other. So using this signals, our master and slave are going to communicate with each other. So this bundle of signals, we are going to call it as a bus. And the protocol which we are learning is AHB. So that is nothing but advanced high performance bus. Okay. So basically we are going to learn the signals. So what is the signal is used for, and how the master is using that particular signal, and how it is using it for sending the data, how it is using for sending it for write operation, read operation, everything we are going to see. Yes. And coming to this master, it is going to provide the address, control signals and data during the read and write operations, and only one manager can control the bus at a time for avoiding the conflicts. For example, if we have multiple masters connected to a single bus, let's say if we have a multiple masters connected to a single bus, let's say if we have multiple masters communicating with multiple slaves connected with a complex bus structure, then only a single master can access the bus at a time, and only a single master and slave can communicate with each other. Okay, that and all we are going to learn in our further discussions. But for now in our whole discussions, we are going to consider only a single master and a single slave, so that the discussions will be simplified, so that the discussions will be simplified and easy to understand. We are not going to complicate the things. Okay. Yes. And coming to slave, So basically the slave, the subordinate responds to the manager's request. Why it is becoming a slave? Because it is responding to the manager's signals. It is not initiating. Slave is not a component which initiates, but it responds to the transactions. Okay. So subordinates include memories. You can also use peripherals, or it can be bridges to other buses like APB. Okay. So this example we are going to see in our discussions also. And if the address sent by the manager does not match any subordinate, the response is considered as invalid, obviously. Okay, that we are going to see further. Okay, yes. And this is a typical diagram which is showing a single master where it is being communicating with three multiple slaves. So we have a single master, or you can also say is a manager, and we have three subordinates: subordinate 1, subordinate 2, subordinate 3. Or you can also say this subordinate 1 as a slave, and slave 1, slave 2, slave 3. Now this is very important to understand. Now let's say if our manager wants to communicate with subordinate 1 or slave 1, let's say if our manager wants to communicate with subordinate 1 or slave 1, how it is going to communicate with the subordinate 1 or slave 1 first? So there are basically two steps we are going to so basically how the manager it is going to communicate it with the subordinate one. So basically here for every slave, here for every subordinate, there will be address allocated for that. Okay, so let's say this is address 1 and this is address 2, and let's say this is address 3. So for every subordinate, there will be an associated address related to that particular subordinate. So if master provides that particular address which is related to that particular subordinate, then only there will be a communication established between that particular manager and the subordinate. Here the address plays a crucial role for selecting which subordinate should communicate with the manager in a multiple slave configuration, multiple slave and single master configuration. Here address is very important for choosing which choosing which slave it wants to communicate with. So for decoding that particular thing, we are going to use a arbiter circuit. So this is how your arbiter circuit is going to look like, where we have a decoder and a multiplexer input, and we have a multiplexer. So this structure we are going to learn further, and what are the signals we are going to see later. Okay, we are going to come back to this entire structure after our discussion of our signals and everything. Okay, now we are not going to touch this because we don't know what is this HW data signal, what is this HAddress signal, we don't know anything. Okay, so first let us try to understand what are the signals and how the master is communicating with the slave, and how the write transfer is happening, how the read transfer is happening. After learning all the things, we are going to come back to this diagram and we are going to see. Okay, for now what is that we should understand is, if a manager, if it wants to communicate with multiple slaves, if it wants to pick up a particular slave from multiple slaves, then it is going to use a address signal, and it should provide the address corresponding to that particular slave, so that there will be communication established between the slave and the master. That is needed for now. Okay, yes. Now let us try to understand what are all the signals which are associated with our manager. So let us try to understand what are the bus signals which are associated with our manager. So this is our manager block diagram. So let us try to understand what are all the signals which are associated with our manager. So the very first two signals are our global signals. So these are shared by each and every, so these are common to your manager as well as your slave. So these are your inputs for your manager. So first signal is HResettle. So it is an active low signal. So this is an active low signal. That means if this particular signal is equal to 0, then your master will be reset, and if it is 1, then it will be no reset. Okay, so this is HReset signal. Why it is global signal? Because for the slave also these two signals are inputs. Okay, and these are common signals for your slave as well. So coming to this H clock, it is a clock signal which is given to manager, and if you observe, we have a letter H before all the signals. What is this H? So in AHB protocol, every signal is going to be represented with this letter H. So if you want to write down a signal data, so you are going to use a letter H. So this indicates it is belonging to AHB protocol. Why we are using these letters? Because in the case of APB protocol also we will have the W data signal. Now if we want to distinguish this W data signal from the AHB W data signal, we need some representation, so that's why we are using this H. Okay, and in the case of APB protocol we are going to use P. So this is for APB protocol. Okay, so this is what it is given in the specification. So in the specification also, if you can see, the signals, everything will be represented with H, letter H, and in the case of APB protocol specification, every signal will be represented with the letter P. Now coming to transfer response signals, let us try to understand what are the transfer response signals we have. So the transfer response signals, first one is HReady. So this HReady, it's the input for our master. It's the input for master, and this is output for our slave, and this is output for slave. Now what is this HReady, what it is indicating? Let us try to understand. So let's say this is our master, and this is our slave. So let's say this is our master and this is our slave. Now so what we have seen in our previous discussions is master is a component which is going to initiate some transactions. It may be a write transaction or it may be a read transaction. Okay, that is what we have seen. Now so master, it is not going to simply initiate the transaction. Like let's say suppose if I want to conduct a class or if I want to take a session, so without your interest or without you all joining the session, if I start taking the session, okay, so if I start taking the class and if I start talking something, who will listen that? And what about my efforts teaching this every content? Okay, there is no use. Okay, so here also same. So if the slave is not ready for the transaction, then what is the use of master sending some data, or what is the use master asking for some data? No use, right? So if slave is not ready for any type of transaction, then what is the use of master conducting what is the use of master initiating some transaction? So here there is a dependency. So the master first, it will check for the readiness of the slave. Here the master, it is first going to check for the readiness of the slave, whether the slave is ready for the transaction or not. If the slave is ready for the transaction, then the master starts the transaction, or if the slave is not ready for the transaction, then the master is not going to start any transaction. So how master will come to know whether the slave is ready or not? Using this HReady signal. So the HReady signal will be output for our slave and input for our master. So this HReady signal is going to tell the master whether the slave is ready for any transaction or it is not ready for the transaction. So by observing or by sampling this HReady signal, the master will come to know, okay, whether should I start the transaction or whether should not start any transaction. So this HReady signal is also going to play very important role that we are going to learn in our further sessions in the burst transfers or in the single transfers. This HReady is going to this HReady is being used a lot. So this is very important. So coming to this HReady, if it is equal to 0, slave not ready, and if HReady is equal to 1, slave is ready for the transaction. So this is how we are going to decide. This is how the master, it is going to decide whether the slave is ready for the transaction or whether the slave is not ready for any transaction, by observing or by sampling the HReady signal. Okay. Now coming to HResponse signal, like let's say suppose after Like let's say this HResponse, you can relate it with like I will be asking, right? So after explaining everything, is it clear or not? So you will be giving some responses. It is clear or it is not clear. So whether my content you can able to understand, or whatever I am delivering, whether you can able to process it or not. So I'm getting some response from your side. Okay. Same like this, after any transaction, or it may be a write transaction or it may be a read transaction, the slave will give some response whether the transaction has been successful or whether the transaction is not been successful. So this HResponse signal is also input to our master and output to our slave. So this HResponse is also output to our slave and input to our master. So using this HResponse, the master, it is going to decide, okay, the transaction has successfully completed. If HResponse is equal to 1, okay, the transaction has successfully completed. If HResponse is equal to 0, then there will be definitely an error. So the master will come to know, okay, there is an error. It will come to know. Okay, so HResponse, it is going to depend upon, if HResponse is equal to 1, then okay, successfully done. But if HResponse is equal to 0, it is given by your slave, then there will be some error, definitely. So this is how the master, it is going to decide whether the transaction has been successfully completed or the transaction has not been completed. So using this HResponse signal, the master is going to decide what to do. Okay. And coming to HR data signal. So before going to discuss about this HR data signal, first of all, let us discuss about this HWrite signal. Next, coming to this HWrite signal, this HWrite signal, it is going to decide whether the transaction happening, whether it is a read transaction or whether it is a write transaction. So if HWrite is equal to 0, if HWrite is equal to 0, it is a read transaction, read operation, and if HWrite is equal to 1, it is going to be write operation. Now let us try to understand what do you mean by write operation and what do you mean by read operation. So in the case of write operation, the data direction is from master to slave. So this is HWrite is equal to 1. So whenever your HWrite is equal to 1, the data will transfer from your master to the slave. And whenever your HWrite is equal to 0, that is a read operation, and the transfer and the direction is from slave to your master. That is, master is reading the data from the slave. So this is HWrite is equal to 0. This is read operation and this one is a write operation. So depending upon your value of HWrite, we are going to check whether it is a write operation or read operation. In the case of write operation, the data direction is from master to slave, and in the case of read operation, the data direction is from slave to master. Now coming to next signal, which is known as HAddr. So this is nothing but our response. HAddr is nothing but our address signal, and till now whatever the signals which we have discussed, like HReset, HClock, and HReady, HResponse, and HWrite. So these are all only 1-bit signals. Okay. Now coming to HAddress, it is of 32-bit signal. So the size of your HAddress is 32 bits. So the size of your HAddress is 32 bits. So why this HAddress we are going to use? We are going to use HAddress a bit. So this HAddress is output to your master. So this HAddress is output to your master. And what is the use of using this HAddress? The first requirement or the first use case of this HAddress which we have seen previously is for selecting your slave. Okay, if we have multiple slaves and for choosing one particular slave, we are going to use this HAddress. And there is one more use also for using this HAddress that we are going to learn when we start about data transfer in this protocol. Then we are going to learn about the next use case of this HAddress. Okay, so for now we only know the first use case is this HAddress is used for slave selection, and there is one more use case also that we are going to learn in our transfers. Okay, and coming to next one is HSize, which is of 3 bits. So this HSize is of 3 bits. Now what is this HSize? First of all, this HSize is output to your master. I will write down here. So this HSize is of 3 bits and this is output to the master. This HSize is of 3 bits and it is output to the master. Basically this HSize is used to define the size of the data item. Define the size of the data item. Like let's say suppose if you are having your master and slave. Let's say we are performing write operation, that means HWrite is equal to 1. Okay, that is HWrite is equal to 1. That means the master is sending some data to the slave. So let's say the master is sending one packet to the slave. Then what is the length of this packet? That is decided by HSize. The length of the packet is decided by HSize. So HSize basically decides the length of the packet. That is, master is going to tell the size of the packet using HSize signal. So HSize is of 3 bits, right? So HSize is of 3 bits. HSize is of 3 bits. 3 bits means total 8 combinations will be possible. 0, 0, 0 to 1, 1, 1. That means if the HSize value is 0, 0, 0, that is the master is sending 1 byte of data to so on. Okay, that we are going to see in our protocol specification. This session agenda is to just get a brief idea about what are all the signals which are associated. Okay, so this HSize, it is going to decide what is the size of the data, what is the size of the data packet the master is sending to the slave. So that is what this HSize is used for. Okay, now so the slave will also come to know, after sampling the HSize signal which was given by the master, the slave will also come to know what is the length of the packet the master is sending. Okay, so that slave will also come to know by seeing this HSize. And coming to HBurst, this is also a very important signal and it is of 3 bits width. So this HBurst is also of 3 bits width. Now what is this HBurst? Let us try to understand. I'm not going to discuss this HBurst in detail in this session. We are going to discuss it in more detail in our upcoming sessions when we are going to discuss about this. And this HBurst is of 3 bits. That is, here also we are going to have total 8 combinations from 0, 0, 0 to 7, 1, 1, 1. Okay, now this HBurst, we have different type of combinations. Like if it is 0, 0, 0, it is single increment, and we have RAP 4, RAP 8, INCR 4, INCR 8. Okay, that is the different type of burst which we have. First of all, let us try to understand what do you mean by burst first. Okay, so let's say if we have a master and we have a slave like this. Okay, so we have a master and we have a slave like this, and let's say we are performing a read transfer. Okay, now so let's say if the master wants to read 4 packets of data, let's say if the master wants to read 4 packets of data, then there will be 4 packets of data, 1, 2, 3, 4. Basically your HBurst is telling the count of your packets. Basically your HBurst is telling the count of the packets, how many packets we are actually reading. Okay, still it will discuss more, like what is INCR 4 or it is RAP 8, that and all we are going to learn further. But for now, what is to be understood is this HBurst signal is just used for counting the number of packets, for how many number of packets we are going to get. And using this HBurst, we are nowhere knowing the size of the packet. Using HSize, we are going to know the size of the packet. Using HBurst, we are going to count the number of packets which we are going to get. Okay, or in the case of write transfer, the master will tell how many packets it is going to give. And nowhere HBurst is going to tell what is the size of the packet. If you want to know the size of the packet, then use one more signal which is known as HSize. Okay, so using this HBurst, it is going to tell in a transfer how many packets a master it is going to send. So that is the use of this HBurst. So HBurst defines the burst mode of AHB transaction, specifying how many data transfers occur in a single burst. So it is going to determine whether the transfer is single, incrementing, or rapid burst. Okay, that we are going to see. And coming to this HPROT and HMarsLog, these are our optional signals that we are not going to discuss in our discussions. These are optional. If you want to refer them, you can refer it in AMBA AHB specification. There is a official specification which is already present in Google. You can refer this AMBA AHB specification doc for learning this two signals. Okay. Now coming to HTrans, this is of 2 bits width. I'll write down here. So coming to this HTrans, it is of also 2 bits width. Now what is this HTrans? So 2 bits means we have 4 combinations, 0 0 0 1 1 0 1 1. So here 0 0 means it's idle, and 0 1 means busy, non-sequential, and followed by sequential. So basically if HTrans is 0 0, so this will be set by our master. This is output for our master. Now this HTrans, it is equal to 0 0. That means master is idle. It is not involved in any other transaction. So the slave will come to know whether the master is busy or whether it is idle using this HTrans signal. Okay. So if master sets this HTrans signal to 0 1, that means master is busy. So that the slave will come to know, okay, the master is busy. So using this HTrans signal, the slave will come to know whether the master is busy or whether the master is idle. And what do you mean by non-sequential and what do you mean by sequential? That is, we are going to learn in our further sessions. Okay, when we start about transfer, then we are going to discuss about this non-sequential and sequential. For now, we should only understand the two conditions. One is idle and another is busy. And followed by HR data and HW data. So these are our data buses. So let's say if this is our master and this is our slave. In the case of write operation, that is HWrite is equal to 1. This is a write operation. And how the master it is going to send the data to the slave? So it is going to use a bus, or it is going to use a signal which is known as HW data. So using this signal, it is going to send the slave the data. It is going to send the data to the slave. Okay, and the width of this is 32 bits. So the master can send 32 bits of data. Okay, and coming to R data and coming to HR data, it is a read data bus. So let's say this is our master and this is our slave. So this HR data bus, so using this HR data bus, the slave is going to send the HR data. So using this signal, the slave is going to send the master the data, and it can also support 32 bits of data. So this is how the master is going to send the data to the slave, and slave is going to send the master data. So these are the signals which are associated with our master. So the first one is reset signal, which is an active low signal, followed by HClock signal, HReady signal, HResponse signal, HR data signal. These are all our inputs, and HReady, HResponse, and HR data. These three signals are given by our slave. So HR data, whatever we are seeing here, so this HR data, HResponse, HR data, these are given by our slave's output, and this all are our master's output and slave input. These are given to our slave. This is also given to our slave, and these are our master's outputs. So using this signal, our master and slave are communicating with each other and transferring the data. not yet happened, not yet completed. Still we are going to learn, okay, how they are going to exactly transfer and how they are actually transferring. Okay, just in this session just in this session we have learned the overview of all the signals, overview of the protocol, and what are all the signals associated with it, what is the meaning of the signal. In detail we are going to learn it. Okay, so what is what we are going to learn. So this was about today's session. So in this particular session we have learned about AHB protocol overview and overview of all the signals, and just overview, little touch and little knowledge about all the signals. And in our upcoming session we are going to learn about basic transfers, how the write transfer is happening, how the read transfer is happening, how address, HReady we are utilizing, and how we are utilizing all the signals for establishing and communicating of data. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. And I wanted to know the feedback of this particular session for sure. So depending upon the feedback only, I'm going to launch the second session. So depending upon the feedback and everything, I'm going to launch the second session. Okay. Yes. So that's all about this video. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.